This video, I will explain the average information content per symbol. It is also called as entropy. The average information content. The average information content. That is entropy of symbols in long independent sequences. In long independent sequences. The average information per symbol. The average information. The average information per symbol. That is entropy H. H is equal to I total by N is equal to sigma I is equal to 1 to M Pi log 1 by Pi base 2 bits per symbol. Bits per symbol. This is the derivation need to be proved. Generally, in a practical communication system, we usually transmit a long sequence of symbols from an information source. Thus, we are more interested in the average information that a source produces than a information content of a single symbol. This is the information source. This is the information source. In practical communication system, this information source transmit a long sequence of symbols. Long sequence of symbols. Long sequence of symbols. We are more interested in the average information that a source produces than the information content of a single symbol. We are concentrated on total symbols information than single symbol information. Total information content of all the symbols which are generated from the information source need to be considered than a single symbol information content. That is the average information. Now we will concentrate on average information. Again, this one is a information source. This information source emits m possible symbols. Emits m possible symbols which are S1, S2, and so on, Sm. These symbols are statistically independent with each other. Statistically independent with each other. That means the probability of occurrence of particular symbol during a symbol time interval does not depend on symbols emitted by a source during the preceding symbol intervals. That means present symbol generation does not depend on the previous symbols generation. This is an information source emits m symbols. The symbols are represented by S1, S2, and so on and so forth, Sm. These symbols are statistically independent with each other. Statistically independent with each other means the probability of occurrence of present symbol does not depend on the preceding symbols. Let P1, P2, let P1, P2, and so on and so forth, Pm, be the probability of occurrence of the M symbols. Suppose consider a long message. Long message contains N symbols. That means the symbol S1 will occurs P1 into N times. The symbol S2 occurs P2 into N times. The symbol SM occurs PM into N times. That means in a long message contains N symbols. In a long message contains capital N symbols. A message contains capital N symbols. That means the symbol S1 will occurs on the average P1 into N times. The symbol S1 will occur on the average is equal to probability of occurrence of that symbol S1, that is P1, into the number of symbols in the long message. The symbol S2 will occur on the average P2, probability of occurrence of that symbol S2, that means P2 into N times. That N times the symbol is repeated in that message, and so on. The symbol SM will occur on the average is equal to PM, probability of occurrence of that symbol SM, that means PM into N times, PM into N. This is a long message sequence, a long message, not sequence, a long message contains N symbols. Next important point here is the symbol S1 carries amount of information. Or information content in the symbol S1 or amount of information in the symbol S1 is I1. That is equal to I1 is equal to log 1 by P1 base 2 bit. The symbol S1 will occur on the average. The symbol S1 will occur on the average is equal to probability of occurrence of that symbol into N times. P1 into N times occurrence of the symbol S1 carries amount of information is it is I1 total. Therefore, I1 total is equal to I1 total is equal to I1 into P1 into N bit. P1 into N, I1 is equal to log 1 by P1 base 2 bit. And similarly, symbol C2, symbol not symbol S2 not C2. Symbol S2 carries amount of information is I2. Therefore, I2 is equal to log 1 by P2 base 2 bit. The symbol S2 will occur on the average P2 into N times. P2 into N times occurrence of the symbol S2 carries amount of information is I2 total. Therefore, I2 total is equal to I2 into P2 into N. I2 total is equal to I2 into P2 into N. Therefore, P2 into N, I2 is equal to log 1 by P2 base 2. And so on and so forth. The symbol SM carries amount of information is IM. Therefore, IM is equal to log 1 by PM. PM is the probability of occurrence of that symbol SM base 2 bit. The symbol SM will occur on the average PM into N times. PM into N times occurrence of the symbol SM carries amount of information is IM total. Therefore, IM total is equal to IM into PM into N bit. IM total is equal to IM into PM into N. Therefore, this one is bit. PM into N. Therefore, IM is equal to log 1 by PM base 2 bit. Therefore, concentrate on total information. Total information is I total is equal to I total is equal to total information. Total information content of the message. Total information content of the message. The message contains n symbols. N symbols means S1 n times repeatedly occurred in the message. S2 n times repeatedly occurred in the message. SM repeatedly occurred in the message. That is called as long message. Total information content of that message is I1 total plus I2 total and so on so forth. IM total. I1 total is n into P1 log 1 by P1 base 2 n into P2 log 1 by P2 base 2 and so on so forth. IM is PM into N log 1 by PM base 2. That is equal to N into P1 log 1 by P1 base 2 plus P2 log 1 by P2 1 by P2 base 2 and so on so forth. PM log 1 by PM base 2. That is equal to I total by N is equal to P1 log 1 by P1 base 2 plus P2 log 1 by P2 base 2 and so on so forth. PM log 1 by PM base 2. That is equal to sigma I is equal to 1 to m pi log 1 by pi base to bits per symbol. Bits per symbol. H is called as entropy, source entropy. This one is H is called as a source entropy. Source entropy is equal to I total by n, where n is called as number of symbols in the message. This is a total information, total information content of the message, total information content of the message by number of symbols in the message. Capital N is the initially defined number of symbols in the long message. Number of symbols in the message. H is called as sometimes source entropy, average information per symbol. Average information per symbol. Not symbol. Unit is average information unit is bits per symbol. The number of bits are which are used to represent the average information, that is unit is bits per symbol. This is also called as a source entropy. This is also called as source entropy.